Thank you for joining this lesson. We are going to do a question from the equation of a straight line and gradients. So we are told to find the angle between the following lines: y equals to 2x plus 3 and y equals to half x minus 2. Remember to subscribe to this channel and to also share the link with your friends. So we are going to look at how such a question can be handled. In the first case, we are first of all going to get the angle made by each line and the x-axis. For instance, taking the equation of the first line, y equals to 2x plus 3, we know that in case this equation is plotted, then we are going to have a straight line which is cutting the y-axis at 3, such that, because according to the equation of line, y equals to mx plus c, the constant at this point gives us the y-intercept. Therefore, this straight line will cut the x-axis, the y-axis in such a manner. The y-axis in such a manner. That means this line is going to make a certain angle with the x-axis. And again, we should understand that from the same general equation, the value of m, which is the coefficient of x, gives us the gradient of the line. So which means for the first line, the gradient is going to be 2, because the value of the coefficient of x gives us gradient. And for this equation, then we have our gradient as 2. So this means, with reference to this angle made here, then we can say that the gradient is given by change in y, change in the coordinates of y, divided by change in the coordinates of x. Change in y with respect to change in x. This one gives us the gradient. Therefore, gradient is given by change in y out of change in x. And again, we can relate another quantity which we call the tangent of an angle. The tangent of an angle is also given by the opposite, which will be change in y out of the adjacent to this angle, which is going to be the change in x. So we can all conclude that the value of the gradient will also give us the ratio between the opposite side of this angle to the adjacent side of the same angle, and that means gradient is equal to the tangent of the angle, which is going to be 2. Therefore, for us to get the angle here, the first angle made by this line and the x-axis is going to be the tan inverse of 2. And the tan inverse of 2, shift tan of 2, is going to give us 63.43. 63.43. So this one is the angle between the first line and the x-axis. Again, we can consider the second equation, whereby we will say now the second gradient is going to be half. And now if the second gradient is going to be half, and the line is cutting the x-axis at negative 2, such that the line is going to behave like this, then it means, again, this line will also be making a certain angle, beta 2, with the x-axis. And now we can move ahead to evaluate the value of beta 2, such that now, again, the second beta will be equal to the tan of the second beta, which is 2. This means to get the value of the second angle made by the second line and the x-axis, then we are going to evaluate the tan inverse of half. Therefore, the tan inverse of half, shift tan of half, we are going to get 26.56. 26.57 degrees. 26.57 degrees. Now, whatever we are evaluating is the angle between the two lines, which means now, if we got two lines such that one makes an angle of 63.43 with the x-axis and another one makes an angle of 26.57, then we can get the angle between the two lines, because at some point the lines are going to intersect. This means if one of the angles, if we take this one as our x-axis now by translation, then we find this line is making 26.57 and this other one is making a complete angle of 63.43. So this means now the angle between the two lines is the difference between these two angles. Therefore, the angle between the two lines is when we get beta 1 and we subtract beta 2. This is going to give us 63.43 and we subtract 26.57. Therefore, when we take 63.43, we subtract 26.57, we're going to get 36.86. 36.86 degrees. So this is going to be the angle between these two lines. Thank you for following, subscribe and share.